Hello students, welcome back to this lecture series of mathematical methods in physics, M.Sc. part 1, semester 1st. Okay, in the last class we discussed some property of the Hermite polynomials. In this lecture we are going to discuss one property, that is orthogonal property of the Hermite functions. Okay, so this orthogonal property for the Hermite functions is integrations over minus infinity to plus infinity e raised to minus x square into hn x into hm x dx is equal to 0 when m is not is equal to n, and 2 power n into n factorial into under root 5 when m is equal to n. Okay, so this is the orthogonal property of the Hermite function, and this hnx into hm, this is the two polynomials of the Hermite functions. Okay, so we are going to prove this thing. Okay, so here are the two conditions. When m is not equal, then this integrations is equal to 0. Okay, and when it is equal, m is equal to n, means this n, this polynomials here n and m. So this, if this thing is equal, so result of this thing is 2 power n into n factorial into under root 5. Okay, so here we are going to consider the two polynomials and related with the generating function of the Hermite functions. Okay, so we know the generating functions of Hermite functions. So it is e raised to x square minus x t1 minus x bracket square. Okay, so this is the Hermite functions of the generative function of the Hermite functions. So this equal to summation over m is equal to or n is equal to 0 to infinity into hn, the function of x into t power n by n factorials. Okay, so this hn, this is nothing but the polynomial of the Hermite functions. Okay, the coefficient of the t power n by n factorials. Okay, so this is one generating functions. Now another generating functions we consider, that is e raised to x square minus t2 minus x square is equal to summations over m is equal to 0 to infinity hm, the function of x, into t power m by m factorials. Okay, so this two generative functions we relate with the hn and the hm. Okay, so now if we take the product of these two things, e raised to x square minus t1 minus x bracket square into e raised to x square minus t2 minus x bracket square is equal to summation over, you can write m in, or m is equal to 0 and n is equal to 0 into t power n into t1 power n into t2 power m divided by n factorial into m factorials. Okay, so this is after we taking the product of these things. Okay, so here if we think about this power of expansions, that is e raised to x square minus t1 minus x bracket square plus x square minus t2 minus x bracket square is equal to this thing. Okay, so we just we try to solve this this power of e. So it is x square minus t1 square minus 2x t1 plus x square plus x square minus t2 square minus 2x t2 plus x square. Okay, so if we open this brackets, so this minus sign is multiplied to this whole brackets. Okay, so it is x square minus t1 square plus 2x t1 minus x square. Okay. And here plus x square minus t2 square plus 2x t2 minus x square. Okay, so here this will be cancelled out, and minus t1 square minus t2 square plus 2x t1 plus 2x t2. Okay, so these things we can write like this: e raised to minus t1 from here, t1 square plus t2 square into e raised to 2x t1 plus t2. Okay, so left hand side of this equations now is this: e raised to minus t1 square plus t2 square into e raised to 2x into t1 plus t2 bracket. So we can write e raised to minus t1 square plus t2 square into e raised to 2x t1 plus t2 is equal to summation over into m factorials. Okay, now multiply to both sides by the e raised to minus x square to these expressions and integrate over the limit minus 2 plus infinity. Okay, so if I minus 2, so we can write e raised to minus t1 square plus t2 square integrations over minus 2 plus infinity, and if we multiply with this e raised to minus x square, so it is e raised to minus x square because we integrate with respect to the x. Okay, so this here power is only function of t, so that's why I take out the outside of the integration. So e raised to minus x square plus 2x t1 plus t2 dx is equal to, okay, so here integration over minus 2 plus e raised to minus x square. Okay, this minus x square we multiply both sides, and 2x into t1 plus t2 is equal to e raised to minus x square mx into mx t1 power n into t2 power n m divided by n factorial into m factorials over dx. Okay. So now here we are going to use the one standard formula, that is integration over minus 2 plus infinity e raised to minus ax square plus 2bx into dx is equal to under root pi by 2 e raised to b square by a. Okay, so this is a standard formula we are going to use for these expressions. Okay, So here if we compare this with this formula, so A is equal to 1, okay, and B is equal to T1 plus T2, okay. So if I put here, so pi you get okay. So from these expressions we can write e raised to minus T1 square plus T2 square into e raised to, sorry, it is not raised to. So from this formula we can write under root pi e raised to 2 T1 into T2, okay, sorry, T1. So B is equal to T1 plus T2, so here is a B square, so it is T1 plus T2 bracket square, okay. So is equal to, now next thing is as it is, so it is we are going to expand this thing. So if under root pi and this e raised to minus T1 square plus T2 square, and if I open this bracket, so it is e raised to minus T1 square minus T2 square plus T1 square plus T2 square plus 2 T1 into T2, okay. Expansion by expanding this bracket T1 plus T2 bracket square and multiply with this e raised to minus T1 square plus T2 square, so we get these things and we can cancel this one, okay. Now left hand side is equal to under root pi e raised to 2 T1 into T2, okay. Two T1 into T2 is equal to, this is square, okay, for the n, e raised to 2 T1 into T2 is equal to this right hand side, so it is minus to plus infinity e raised to minus x square h n x into h m x divided by T1 power n. Here is a power n, if you consider for the n thing, to power n by m factorial into n factorial into dx, okay, okay. So here this T1 power n is equal to, or the T2 power n, T2 power n is equal to 2, there is power n, okay, T2 power m is equal to T1 power n into delta n m, okay. Here is m, when the m is equal to n is equal, then it is equal to 1, this delta nm is equal to 1, and when is equal to 0, when the m is not is equal to n, okay. So this is the relations, m is equal to n, then this delta nm is equal to 1, and when it is not equal, then it is equal to 0. So these relations I am going to use here, so it is e raised to minus to plus infinity e raised to minus x square h n x into h m x T1 power n. So here we can write, this is e raised to 2 T1 into 2 T2. So this thing 2 power n like this, under root pi e raised to 2 power n into T1 power n into, okay, and here that is n factorial and the m factorial, okay. So Okay, so here if I put the t1 power n is equal to t2 power n into delta nm, then compare the coefficients of the t1 power n into t1 power n, so we get a relations, that is minus to plus infinity e raised to minus x square h n x, and this h mx is equal to dx under root pi e raised to 2n into t power. So if we compare the coefficients of the t power n into t power n, so it is like this 2 power n by n factorials, because this n factorial and n factorial we can take here, and so relations we get like this under root pi into 2 power n into n factorials. So here this delta mn is equal to 1, because m and n is not equal. Okay, so for these conditions we get the these relations under root 2 pi 2 power n by n into n factorials. Okay, if it is not equal m and n, then it is equal to 0. Okay, so this is orthogonal property of the Hermite functions. Okay, so let's stop here. We'll discuss in the next lecture.